We're on the foreshore of the Manukau Harbour at Ihumātao, and we're about 2 kilometres west of Auckland's airport. And we've come to look at a fossil forest. So how come we can see these fossils here? If we imagine this forest was growing here, it died and then was buried and preserved for many tens of thousands of years before the sea just recently has come in and eroded away that rock so that we can see the forest laid out on the shore platform here. And in this instance, the wood is as fresh as it was when it was living almost. We've got this trunk of a tree that's fallen over and it's now lying flat. But if we come over here, this in fact is the in situ stump of the tree, and the trunk has fallen over and the stump is still sitting here with its roots going out in all directions. And so we have the trunks that have fallen over and the stumps that are still in position. So here's some gum, and not many New Zealand trees have gum like this. And this is kauri gum inside the wood. 1, 2, virtually 3 metres diameter across that stump. So right next to this large stump, we've got this big long trunk of a tree, probably the kauri tree again. I would guess this tree's several hundred years old when it fell over. Let's go over to the cliffs and get some clues as to how they were preserved. Here we are in the low coastal cliffs, and at the bottom of the cliffs we see a clue to why those big tree stumps and logs out there were preserved. And that is that there are 2 different kinds of rock here in the cliff. We've got this lower one, which is all black. That's peat. Peat accumulates in swamps. It's organic material that's decaying and is accumulated in a wet swamp. And the tree stumps and logs out there were all once buried in this black peat in the swamp. Kauri trees don't normally live and grow in a swamp. So maybe what happened here was that the drainage of this flat area changed at the time they were growing there, and it became waterlogged, killing the trees, and they died, and over time in different winds, big winds, they fell over and landed in the swamp in the wet. And once they're waterlogged, that preserves the wood, and they've been waterlogged within the peat pretty much ever since they died. We don't know exactly how old they are, but we presume they're 200 to 300,000 years old when that forest was growing. Now over the top, you can see we've got a lighter coloured rock that goes all the way to the cliff, and it's layered. This in fact we know to be volcanic ash that was erupted from Maungatakitaki volcano, which is only about 400 metres away above the cliff here. And here we can see one of those large stumps that's been preserved in the peat swamp. And over the top of it here, here's some of that black peat that buried that tree stump after the main trunk had fallen off and into the swamp, and then more peat has accumulated on top of it to preserve it. Over here is the peat, and it's a lower level than on top of the tree stump. Originally the peat would have been right up at this level all the way across. But when the volcanic ash was deposited on it, that weight has compacted the peat down to this level, but where the tree stump is, it couldn't compact the tree wood, and so it stayed up at the original level. So we've got the tree stump up high with the peat over it, and the level of the peat has been compacted down on either side. So we've just moved to the side here, and now we can see the volcanic ash, but here we also see there's wood preserved within the ash layers. Now this couldn't be the remains of the forest that was killed and buried in the swamp. This must be the remains of another fossil forest. And it looks as if it was probably growing here on top of the peat when the Maungatakitaki volcano nearby erupted and has knocked it over. Some of the branches have fallen into the tuff and been buried and preserved, as we can see here. And if we walk along, we'll see even further evidence of some of these branches of the forest that was growing here when the volcano erupted. So if we look at the base of the ash here, the deposit, and we pick out a piece near the bottom and break it open, and often we'll see little black pieces of leaf preserved in the lower parts of this ash deposit. In this instance, it looks like a piece of rimu tree. So these explosive blasts, when the rising magma hit the cold groundwater, broke up all the soft rock that was just under the ground into very fine fragments, and it was blasted outwards. A lot of the ash was blasted sideways in what we call a base surge, a hot incinerating cloud containing ash and broken up rock. And that sped across the ground away from the vent for a short distance. In this instance, it stopped about 1 kilometre from the vent. But as it was going, it deposited layer upon layer of ash. So each one of these layers in here represents one of those base surges coming through. Sometimes the blasts were a little bit deeper, and they'd rip off some of the rock on the wall of the throat of the volcano and throw these stronger bits of rock out. And up here we see a large block of sandstone from underneath, maybe 100 metres or so deep in that vent, and it's been thrown out into the air and it's landed in the layers of wet ash. And in fact, up here we can see the impact it's had. It landed in this layer and it's bent this layer down underneath it as it's gone kaplonk into it. So we've got a small impact crater, if you like. But we can also see in here hard, dark grey pieces, quite angular like this. And they're part of the magma that hit the water, was chilled to solid rock and fragmented by the blast and thrown out as well. So in addition to those blocks of harder sandstone from the Ihumātao sandstones, we actually occasionally get large bombs of basalt. This is material that was liquid as it was coming up in the magma and was thrown out and cooled and solidified as it was going through the air and landed in the layers of ash fairly close to the vent. So here we have quite a large block of a very hard rock, and it's a sandy limestone. And it's older than the Ihumātao sandstones. It's about 30 million years old, and it belongs to what we call the Tikawiti group limestones, which don't outcrop in Auckland, don't outcrop at the surface, but must be down below us, maybe 500 to 800 metres below us, is where this limestone's been ripped from in the throat of the volcano and thrown out by the explosive blasts and landed. And there's 2 or 3 scattered around the foreshore, and because they're so hard and resistant to erosion, they sit here long after the ash has been eroded away. So this is the tree trunk of the forest that was growing here at the time of eruption of Maungi about 85,000 years ago. And those base surges came surging across this way, and they clearly have knocked this tree sideways to some extent, and the whole top of this tree trunk has been knocked off and down into the ash over here. Over here, these branches and roots are part of the modern Putakawa that were underneath, so not to be confused with this old fossil tree. As we walk away from the steps and away from the volcano itself, we find still more branches and things lying horizontally that have been knocked over or broken off the trees and landed in the lower layers of the ash and buried and preserved. You go higher up in the ash, there's no branches up there because all the trees had been knocked over by that time. The other thing to note here is that the thickness of the volcanic ash here is only about 5 metres, whereas as you get closer to the volcano, where we were on the corner, it's 10 metres thick. So the ash itself deposit is getting a lot thinner as we move away from the vent. So as the ash gets thinner, these logs and branches that are preserved here are getting closer to the surface, and in the lower parts there's still a bit of wood preserved, but as we get a bit higher, all the wood seems to be getting rotted away. And we think that's because the groundwater level was somewhere in this vicinity here, and when the groundwater level gets below it, it dries out and the air gets in there and it starts to decay, whereas lower down the wood has been water soaked all its life and has been preserved. Now we're only about 200 metres away from the steps, and now the ash is only about 3 metres thick. So here we have the impact crater of another block of sandstone that's been thrown out of the volcano from that direction. It has landed at an angle, landed here, and depressed these ash layers down before they'd hardened and dried out. Over here, about 400 metres away from the bottom of the concrete steps, we can walk up through the very low cliff here and read the whole history of this area over the last 200,000 or 300,000 years. So once again, to remind you, there are two fossil forests here. The older forest of large kauri trees was killed by the swamp coming in. Their trunks fell into the swamp and got preserved, and we got left also with their stumps preserved here. And then the peat dried out, and here we get the second younger forest growing, which grew on top of the dried out peat. But it too was killed, this time by an eruption from Maungatakitaki volcano very close to here. And we get, in this instance, moulds of the upright trunks and moulds of the branches preserved in the ash here. Further up here, there seems to be a central stem running up, and the branches, in fact, are leaves. And when we look closely, we can see it's a kauri leaf. So this is a branchlet of a kauri tree, and here's another kauri leaf up in here. And these have come off, obviously, a kauri that was growing here in the younger forest. On top of this shelf of ash, we've got a layer of conglomerate. Conglomerate is a sedimentary rock with pebbles and cobbles, many of which are rounded. And looking at this, it looks like it accumulated at the back of a beach, but like we have the beach here today. So when was sea level this high water? During the early part of the Holocene, which was about 5,000 to 6,000 years ago. We probably had this high tide beach deposit laid down. So here we have the conglomerate, and we go up through some sandy material that was probably still beach sand, and within here we've got rounded clasts of pumice, rounded pebbles of pumice. There are several possibilities, but one is that it actually came from an eruption from Taupo in the centre of the North Island. It erupted with a large eruption 1,800 years ago. A lot of pumice and sediment came down the Waikato River and then up the coast and into the Manukau harbour here. And so the pumice is floating, and it was thrown up on the back of the beach here. So that may date what was happening here about 1,800, 1,500 years ago. So on top of that layer of high tide beach sand with the pumice in it, we go up and we find a layer rich in shells, mostly cockle shells in here. And in fact, here is a depression that's been dug out. It was probably an umu, a fire for cooking of the pre-European Maori. So the Maori arrived here around about 600, 700 years ago. And so this would be younger than that, when there was a little population perhaps living here by the coast, collecting shellfish and other food and cooking it here. Now if we carry on further along here, that midden extends right along the cliff, and in here we're getting European debris right in the top in the soil. So this is probably since the 1950s. Material has been washed up and then buried by storm debris on top of the midden. And so here we see the history from 300,000 years ago right through to European times.